Hello Cloud Gurus, and in this section I'm going to talk about controlling table performance. Now I don't like the terminology that AWS use when describing table performance. AWS call performance capacity. So when you look at the console or APIs or the command line, you'll see a reference to table capacity. So when AWS talk about table capacity, they're not talking about the volume of data in a table, they're talking about performance. So as we proceed through this lesson, I'm going to try and clear up some of that confusion, but just keep in mind that the two terms are somewhat interchangeable. Let's get started, and by the end of this lesson, it should all make sense. Let's start with a quick refresher, as I covered some of these points when I demoed the AWS console in a previous lesson. Capacity, also known as provision capacity, is a way of providing performance directives to DynamoDB. It's defined on a per table basis. This is key to remember, as many of the advanced data modeling tips that I detail in later lessons rely on the ability to control the values scoped to a table. DynamoDB provides independent controls for read and write, and this is a massively important concept to grasp. In the traditional world of storage, I/O performance is often a composite value. When you define an operations per second, you don't separate this into read and write allocations, and DynamoDB provides the functionality to do so. Performance values can be changed at any time, either via the console, the CLI, or via API calls. A key thing to remember is that changing performance allocation is an asynchronous operation. It may take some time to make the changes in the background, and this is dependent on the time of day, the system load, the amount of data, and the values being set. In practice, it's usually very quick, but do keep in mind it's not instant. Now you need to be deliberate and cautious when you change either the read or write values on a table. Changes are made to the infrastructure based on the values that you're changing, and sometimes the impact isn't what you'd expect. I'm going to hold off giving you advanced concepts during this lesson, but I will be going into this in a lot more detail in the advanced DB partitioning lessons in a later section. When I say be cautious, any increases cost money, but anything over 3,000 read capacity units or 1,000 write capacity units have special significance, and the reasons why will become clear later in this course. For now, just remember that anything over 3,000 RCU or 1,000 WCU needs special consideration. That's not to say it's a problem. DynamoDB can easily cope with much higher values than that, but as an administrator or DB designer, you need to plan for the underlying changes, and these will be detailed later in this course. Now, the last piece of advice I always give about the capacity and performance controls is that an effective DynamoDB administrator should aim to use them for medium to long-term changes. You have close to infinite scalability with the controls, but don't use them for minute-to-minute changes in performance requirements. If you need to change these values more than 3 to 4 times per year, it points to something being wrong with your model, or you're using them wrong or planning incorrectly. And remember, you can only decrease the performance allocation on a table 4 times per calendar day, and calendar days are calculated in UTC. You can increase performance as often as you would like, but you are not allowed to decrease it more than 4 times in every calendar day, and that's on a per table basis. So let's have a look at what these values actually do. So let's start with some jargon. It will make it easier to talk about these things, and you will see the acronyms in AWS literature anyway, so it's useful to clear them up in advance. First up, we have read capacity units, also referred to by their acronym of RCU. And an RCU is a unit of data up to 4 kilobytes in size. So either 4 kilobytes of data or a smaller amount that's rounded up to 4 kilobytes. We also have write capacity units, which are referred to as WCU, and that's a unit of data up to 1 kilobyte in size. And again, that's either 1 kilobyte of raw data or a smaller amount that's rounded up to 1 kilobyte. Now, you as an administrator assign these capacity units to a table on a per second basis. For example, if you give a table 10 read and 10 write capacity units, this allows 10 read operations, each of which can be 4 kilobytes in size, or up to 4 kilobytes in size, and that gives an up to total of 40 kilobytes per second of read. Or you've got 10 write operations, each of which is up to 1 kilobyte in size, and that's an up to total of 10 kilobytes per second of write performance. Now, any operation within DynamoDB, no matter how small, is rounded up to 1 kilobyte for writes and 4 kilobyte for reads. So that's key. No matter how small the amount of data that you're reading or writing, it is always rounded up to 1 kilobyte for write or 4 kilobytes for reads. A getItem operation, which returns one result, will always consume 4 kilobytes as far as DynamoDB is concerned, and a put item will always consume 1 write capacity unit. For larger operations, which are larger than the 4 kilobyte or 1 kilobyte, you always need to round up to the next highest boundary. So if you're writing 11.5K, then you're actually writing 12K. And if you're reading 9K, you're actually reading 12K. You always round up to the next boundary. So let's have a look at some examples. Let's say I wanted to read 3 kilobytes of data from my table. We know that 3 kilobytes is less than 4 kilobytes, so we know we need to round up to 4 kilobytes. But let's follow the process. We take the 3 kilobytes and we divide it by 4 kilobytes, which gives us 0.75. And this is the number of raw units we need. So we round this to the next highest whole number, and that gives us 1 RCU. Another read example, this time 6 kilobytes. So we divide 6 kilobytes by 4 kilobytes, and we know that that needs 1.5 raw units, which we round to the next highest RCU, which is 2. The same logic continues for bigger operations. Let's say we need to read 40 kilobytes of information. So we divide 40 kilobytes by 4 kilobytes, and that gives us 10 units. And 10 units rounded to the next whole number is still 10 units. So we need 10 read units to read 40 kilobytes of data. Now the maths is the same for writes, except that writes are in 1 kilobyte units. So a 1.5 kilobyte write is divided by 1 kilobyte, which gives 1.5 raw units, and that's rounded to the next highest whole number, which is 2. So a 1.5 kilobyte write uses 2 write capacity units. Now, once you know the number of RCU or WCU that you need for one query, you can multiply this by the number of each type of query you expect on that table in a second, and that's your performance, or in AWS wording, capacity allocation for that table. And you can set that using the CLI, the console, or APIs. Now, there is an exception. The above formulas are for all writes and are for strongly consistent reads. Remember earlier in the course where I discussed DynamoDB's consistency model and I talked about eventual or strongly consistent reads. Eventually consistent reads use half of the capacity, so an operation that would take 1 RCU to perform with strongly consistent reads only takes 0.5 units to perform eventually. Now the minimum RCU or WCU on a table is 1, which means that with minimums you could perform 1 kilobyte write per second on a table, or 1 4 kilobyte read per second using strong consistency, or 2 4 kilobyte reads using eventual consistency. Now take a moment if you need to. The above maths is important. being able to perform this mentally is going to make you much faster and more reliable when working with DynamoDB. Even understanding it at a basic level is a good first step. If you need to take some time, pause the video here and run through some different calculations in your head. At a high level, you take the size of the read or writes your operation uses. You divide by 1 kilobyte for writes or 4 kilobyte for reads, and this gives you the raw units required for an operation. You then round that number up to the next highest full number, and that will give you the RCU or WCU for that operation. Now, if that operation is a read, and you are okay with an eventually consistent read, then you can half the RCU requirements for that operation. You can also do the maths the other way around. If you have a table with 20 RCU and 20 WCU, then you can work out that 20 RCU equates to 20 times 4 kilobyte, i.e. 80 kilobyte per second max data throughput for reads on that table. And you can achieve double that by saying that you're fine with eventually consistent reads, and that is the default. So remember, if you don't specify, then you are always going to use eventually consistent reads. And you also know with 20 write capacity units on a table that equates to 20 times 1 kilobyte, and that's a maximum of 20 kilobytes per second for writes on that table. So why not run through a few of these math calculations yourself? Pause the video and get comfortable with doing calculations both ways. So next I want to quickly show you how table capacity and performance settings are updated, and there are three main ways. The first, and the one which the majority of administrators know and use, is the UI, specifically the capacity tab for a table. Now, changing these values are pretty trivial. You update the values and you click save. And another reminder that this is an asynchronous operation, so the changes do not have immediate effect. The next is the update table command when using the AWS command line tools. It accepts the table name and the provisioned throughput switch, and passed to this switch is a JSON object which contains two key value pairs, one for read capacity and the other for write capacity. And as with the UI, this command is asynchronous, so it will come back with an in progress or a failure message immediately, and the actual change will occur in the background. Now, the last method is to use the update table API call, and the exact syntax of this will depend on the language being used, but the basic concepts, inputs and outputs will be similar to the command line implementation. It's worth noting that the update table operation doesn't itself consume read or write capacity units, so from this perspective it can be used as performance needs dictate. But I'll explain further on in the course that this is not always a good idea to regularly run updates to tables. So let's proceed to the next slide, where I'm going to provide a little more information about how data size is calculated and how this relates to WCU and RCU. In the previous slides, I detailed how to calculate the RCU and WCU values appropriate for a given workload on a table. What might not be immediately obvious is working out how big an item is. Consider this example a student table which has a partition key of student ID, which, as you've learned, is the only mandatory attribute in every item. Additionally, we have first name and surname, which can be assumed will be there, but strictly speaking they are both optional. The same can be said of the student's sex. While it is optional, we can assume for the most part it will always be present. For car registration and mobile number, though, we have two fully optional fields. Not every student will have a car, and thus not every item in the table will have this attribute. And while most students may have a mobile, not all will have provided it, and so it won't be recorded in every item in the table. So to calculate the total item size being read, you have to consider the size of the following elements. The attribute values for the item, i.e. for item 1, Joe in the first name, Smith in the surname, M in sex, and the mobile number in the mobile number attribute. Additionally, the attribute names for each item, i.e. first name, surname, sex, car rego, and mobile number. These are stored along with the item on a per item basis, a side effect of the fact that DynamoDB is flexible from a schema perspective, and that also means that key value pairs which represent attribute name and value are stored in each applicable item. If you ever need to aggressively manage performance, picking short, efficient attribute names can make a big difference. The last thing to consider is which attributes are contained in each item. It's a complex process to understand your data, to know the sizes of your items, to know whether attributes are consistent in items, and to know all of these elements for all items in all tables in your database. Knowing all of these elements will allow you to calculate an average or a minimum and maximum item size, and these are critical to be able to pick appropriate read capacity and write capacity values for a given load on your database. Well, thanks for listening, Cloud Gurus, and that's the end of this lesson. If you have any questions about subjects covered in this lesson or any others, feel free to reach out directly or via the Cloud Guru forums. Otherwise, thanks for listening. Feel free to complete this lesson and move on to the next.